Hi, I'm Sherry Conrad with Cisco Global Partner Engineering, and this is a recording follow-up to the LTRAP 3000 Cisco Live Lab. All right, so what we're going to be doing today is using Concourse automation pipelining, which is a pipelining solution of choice in all the large software companies that I have done work for in the past 10 years. And we are going to be building SD-WAN cluster for MSPs. And we're going to be covering more than just enabling multi-tenancy in SD-WAN. Multi-tenancy is much more than that. We are going to be covering how to use a vault to segregate all your artifacts for your different tenants and be one step ahead of security. We're also going to be covering security in regards to ephemeral OCI build containers and why it's important to actually stick labels, tags, and versions onto all the components you are using in your pipeline in case you ever need to roll back. And we're going to be using the rapid iteration agile lifecycle of DevOps engineers. So DevOps engineers, we build a little bit of code and we test it out immediately, and then we deploy it. And Concourse allows us to do those initial tests very rapidly. It enables us to build code extremely fast, and once we have built a lot of automation tasks, we put them into jobs, and then we put those into our pipeline. What is the architecture of our automation pipeline? Well, the code and the ideas go from your brain into your source code repo, which in most cases is not Git. Most software companies have a private repo. They will not trust their source code on any sort of public Git repository. But because this is a lab, we will be using a public Git with a private repo. Goes from your brain into Git, and then Concourse takes it, that Git code, ingests it, builds it on an ephemeral OCI build container that it pulls from Docker. And it builds out the underlay for SD-WAN into AWS and Azure as well as GCP. It places all the artifacts from the build, including the variable values, into a vault. Now, I have not turned on encryption, so we can see the variable values in this lab, but in reality, in real life, you would want to base 64 encode any config files or encrypt them, as well as the variable data. And then it actually deploys the SD-WAN, and you can access this via the GUI. Now, there are some manual steps that are decoupled from the GUI that we will have to do manually. So let's go ahead and let's see this in action. All right, the first thing you're going to do is, once you get access to the private Git repo, and you're going to need an SSH key to push code to your branch, you're going to go ahead and you are going to clone the branch. So as you can see, I have cloned the branch here, and I'm on the release 1.0 branch, and as well I am going to log in to Concourse. Boom, I'm logged in, and now I'm going to set my pipeline. So when I set my pipeline, I'm just calling my environment. I'm calling my pipeline config file, which we'll look at later. I'm giving my pipeline a name and passing it my parameters file. My parameters file essentially just has my git SSH key. So it's going to tell the pipeline to push code to my branch with that key. All right, we're all set up. I'm ready to go. So I'm going to hit enter. I'm logged into Concourse here. My team is main, and you can see there's no US1 pipeline yet. So as soon as I hit enter, I'm going to have a quick preview of my pipeline. Yeah, it all looks good. It's linted. There's no errors, so it automatically lints it. And I'm going to see my pipeline. Boom, there it is. So when my pipeline first deploys, it's in a pause state, okay? As soon as I unpause it, what's going to happen is these jobs with solid lines are going to run immediately. So lab prep is just going out and verifying it can connect into the vault, okay? Concourse is integrated via the Helm chart, via an app role and ID via the vault. So every single call, it is rotating the token, so it has a very secure integration into vault. All right, we're ready to go. Now, I could have set this to run all automatically, but because it's a lab and I want to talk about each job, the first thing I'm going to do is deploy my elastic IPs. We want to use elastic IPs in AWS so that if we shut down or reboot the instances, they retain the same public IP. And as well, in a lab, we may want to delete and blow things out and bring them up again. So in this way, we are sure that the same network interface cards are going to have the same external IPs at all times. Okay, we're also going to go ahead and we are going to deploy the VPC. Okay, so in a future iteration, I could actually have both of these jobs deploy at the same time. All right. Once this completes, what it is, if it's successful, if there's no errors, what's going to happen is these jobs with solid lines are going to automatically kick off. So as soon as the VPC builds, which contains the route tables and internet gateway, the security group with all the firewall rules and so forth, it's going to automatically kick off and deploy the instances. Now the instances are built from AMIs. The AMI IDs are different in each region. And the AMIs are actually built from the VHD that we download on softwarecisco.com. So essentially we upload it to S3 and then what we do is we take a snapshot of it and then we create the AMI from the snapshot and we copy the AMI over to all of the different regions. Okay, so deploy VPC was successful and it was a prerequisite, so it passed its input onto these three jobs. So what's happening now? It's going to deploy 3 vManage, which is the minimum for an MSP cluster, 2 vSmart and 2 vBond. It's going to deploy all the NICs, make sure they're on the correct indexes. So in AWS, you actually have to hard code the NIC to the index. So when it reboots, it comes up on the same index. That's very important. You don't want your indexes to change. Assign those elastic IPs and then it's going to wait till the instances are initialized. Once they're initialized, it's going to automatically configure the instances. And then we are going to have to wait a few minutes until all the services come up before we can actually log on to the GUI. Now, once this builds and there's no errors, we can do a code walkthrough. So actually, let's start that right now because it does take a little bit for the instances to come online. So let's see what the pipeline has auto-deployed so far. So it went ahead and it deployed all of our elastic IPs into AWS and it put all of these allocation IDs into the vault, so that when the instance jobs spin up, they can call the vault and get the proper IPs. All right, we're going to look at that in the code walkthrough. It also deployed the VPC. Let's go to VPCs. So I hit refresh. Yes, so this is the VPC, US West 1A. It deployed all the subnets, public, cluster management. It deployed our route tables, our internet gateway, and our security groups. And we can look and we can see that everything is tagged as per our AZ. We can see all of our rules in here. And one interesting point is that you will not find this in documentation anywhere. I had to figure this out on my own. Even AWS could not help. Is that you need to actually add all of the network cards into a private security group, and then you have to allow all traffic from that private security group into your primary security group with your firewall rules, or none of the network connectivity will work in AWS. I would like to call that out. So the devil is kind of in the details when you're deploying these things. The documentation is very high level, and that is for a purpose, because quite frequently in cloud providers, there will be small changes, and therefore you have to make sure that you are always testing out this stuff, and that's why we use our pipeline. So let's see how far we are, if the instances are up and running. It also created all of our network interfaces here that we are required to create before we deploy the instances. And we should see the instances starting to come up. They are. I had deployed instances earlier today and deleted them. We can see that the instances are currently initializing, and once they are done, they will be automatically configured. Now we are in a tiny bit of a chicken and the egg with the vBond and the vSmart instances. When those instances come up, their index 0 NIC just happens to be on VPN 0 as well. We need to take that NIC and move it onto VPN 512. So when we first configure these and make these changes, we get disconnected. It's a chicken and the egg scenario. So we have to run those jobs twice. So you're gonna see the vManage job succeed and go green. You're gonna see these fail, and they did. And that's because we just changed some configurations on the NIC and we got disconnected. So that's fine. We're gonna run them again and they're gonna succeed. So I'm looking into a way to fix this in the future. Now, one way around this, and it's the way they use in Terraform, is to actually configure the NICs via the user data file. However, you're kind of a one and done. What happens after that? What happens if you need to make changes? That's why I decoupled that and didn't put it in the user data file. I'm doing it through Python. So let's take a look at the code walkthrough. Now, these environments are built from just a couple of variables. And if you look at the actual code here, and you come down to tasks, so the pipeline file is here. There's a couple of different versions. I'm using pipeline v3. The pipeline is essentially just giving a name to a job, and it's giving a plan. So the plan is get my resources. So in this case, again, we're building from one get resource, one branch, and you can either trigger the job automatically with a git commit, or you can trigger it to false. And you can see our Elastic IP jobs, our VPC jobs, our create our instance jobs, or deploy them and configure our configuration jobs, okay? And then you're gonna see at the end resources. This is where you can declare resources in the pipeline. And you can have many different Git branches, many different Dockers. You can have all sorts of resources. We're keeping it really simple here. We're also specifying our vault. And so let's go ahead and look at what these jobs are comprised of. So jobs are comprised of tasks. So all of our tasks are in here. So let's go ahead and look at one of the first tasks, which is deploy the environment, so the VPC. So this job is calling a build container from Docker. It's giving it our input, our resource, which is our Git resource, and is passing in some parameters from our vault. Then what it's doing is calling a shell script. Now we don't have to call a shell script. We can execute the Python directly from here. I like to use a shell script because I can load on some additional troubleshooting tools if I need to, for example, Vim or Netcat, just for fun. And I can also very easily make vault CLI commands to grab variables and pass them in, and then they can be ingested by the Python. So here's the Python that it's actually running, and it looks really long, and that's because this is very basic Python. In a future release, so there's a lot of repetition. In a future release, I'm going to be converting these into modules. It's going to crunch down the code to about half or less than half of what it is now. And we can see on the right our pipeline completed. So within a few moments, we will be able to go in and log into our cluster GUI. Let's hit update lab guide. What this is going to do is going to go out to the vault, and it's going to come back and it's going to give us all our external IPs so that we can make SSH connections in if we like. All right, back to the code walkthrough. So we can see that our Python is calling variables, passing it into the code. So what's our vault token and so forth. It's going to create the VPC here, and then it's going to create all these objects, and it's going to put their specific unique IDs that the AWS API returns. It's going to strip them out of the JSON, and at the end here it's going to write all of those using API calls into the vault. Those are our artifacts. And this is something that Terraform, I mean, you can do it with Terraform, and definitely with Postman. All of those things are visible, and that's a risk, and that's why we don't use those in production. We don't use those in large environments. You have to have some sort of vault integration. So I'm using HashiCorp Vault. Many companies will use the vaults that are native in AWS or Azure, but you need to use a vault, or else, you know, it's just not secure. All right, and then essentially if we go through and we look at our deploy, for example, vmanage, we'll see, again, this is very verbose. So much of these Python scripts are identical except for the names of the instances. And that's because I was doing the rapid iteration, so I may have had an hour or two here and there in between Cisco meetings, and I was just banging out a few tasks at a time. So there's a lot of duplication, and again, in a future release, I will crunch this code and I will turn all of this into modules, and then it will just pass in the variables and do loops to complete the work. But for now, we have a lot of duplication, but that's fine for learning. So we can see that, again, this guy, if we look at the YAML file, right, it's calling a shell. In the shell script, I have made Vault CLI commands, because they're super easy, to grab all the variables I need to grab those artifacts out of Vault so I can build my instances. And you can see them ingested here in the Python. And then it goes through, and it's actually just using check output to take my variables, pass them into AWS CLI commands. It gets the output from AWS, and it strips out the required artifacts from the JSON, writes them to the vault. So this is the methodology, and because I was using rapid iteration, I could write all this code in a couple of months in my spare time very quickly. And this is the beauty about Concourse, is that it allows you to work in this incredibly fast, productive, agile manner that other DevOps tools do not. As well, it is rock solid because there is no local development. Anybody in the world can take this and deploy it into their own environment, and it is guaranteed to work because it is running on a build container. The code's not running locally, so it doesn't depend on local libs or different changes or antivirus on local machines. All right, so let's go ahead, and that was just a brief code walkthrough. So again, very simple Python using check output, using requests. And by the way, this isn't just being used to deploy SD-WAN. Originally last year, I used this to do all the API automation for the FSO labs and training. And as well, I use it for NSO. And as well, I use it to call Ansible and also some Terraform jobs. So it's a one-shop stop, and it's also a single sign-on into any resource. And you can use this not just to build Cisco code, but to build any code in the world, including all of your upper stack applications that run on Ruby on Rails, Go, Ruby, any programming language. All right, so let's go ahead, and we have updated LabGuide IPs. We should see that the interface is ready. And I'm going to do a separate recording now that we're into the interface, but let's just see that we can actually log on to one of these guys. And it doesn't look like it's quite ready yet. Let's just refresh here. Sometimes the services take a little while to come up, so we can see that they're all built, they're all running, and our vmanage one is here. And we can take a look and see that our networking cards are all tagged here. So we have vmanage 1 index 0, that's our VPN 0, and we have 1 and 2, so our 3 network cards. And if we wanted to drill down, we could see that these have been plunked onto the appropriate subnets. Yep. And so, yeah, there it is, public, so perfect So everything is good and deployed here to AWS. And by the way, I am just showing you the AWS view because it is familiar. You absolutely don't need it because you have all the standard out in the pipeline output. So let's just see if we can even SSH to this, because quite frequently we can SSH much sooner than we can access the web service. So 197. So I'm going to copy this. I'm going to go back to my IDE. And by the way, the ED25519 key that was pushed onto these devices via the pipeline is in the vault. I've already set that up here. So I'm going to do an SSH -I, my key, admin @ and let's see if this guy is responding yet. It's not quite responding. So the NMS services can take 5 to 10 minutes to come up. Usually I will do a telnet. Okay. So again, services take a while to come up. What we can do is we can do a shortcut here, and sometimes if things are taking a really long time, I can just come in here and I can do a EC2 serial console connection. We can just see if it is responding. Yeah, it's not responding. Oh, there we go. Okay, it looks like it's ready now. So let me go back to here. There we go. Yeah, it is responding now. So I do not need to serial console. I can just SSH onto here regularly. And I'm going to do SSH -I, admin @ the IP. Okay. It's responding on port 22, but evidently it's going to take a few more minutes to log on here. Yes, here we go. Perfect. So we can see that our automation pipeline configured this guy correctly. And let me just show you, if I were to come here, vmanage 1, and I scroll down, I will see that my pipeline, I have told it to do a show int of the interfaces, and also it spits out the show run. And so let's just go ahead and we'll do it as well from here. So let's do a show int t. Yeah, and we can see that ETH0 is correct on VPN 0. It's on the 10.101. We can see that this one is on VPN 0. We should probably actually remove that. That's a misconfiguration. This should not be on VPN 0. This is the cluster IP. So we can change that. That'll be a fun exercise. Interestingly enough, it will still work like this. And then we have on VPN 512 our ETH1, which is our 10.102, which is our management subnet. So this will work the way it is, but we'll make a little tweak a little bit later on using an automation task to move this guy off of VPN 0. All right, let's do a show run. And we can see that our automation worked. It named our machine. It gave it the system IP that we told it to. It gave it the proper organization name for our MSP provider. And if we come down here, we will see that it, and oh, by the way, it also set the password. That's how I could log on. We can see here that it has set up VPN 0 correctly, that it's allowing service netconf. This is all good. And we can see that everything else is configured correctly. And if we were to go over and look at this in our code, and we go into AWS configure vmanage, and we look at vmanage 1, this is the Python script that configured that. And so this is just using netmiko. Now, before we can access the API and start doing automation with the API, we actually have to do this basic, I believe this is the day 2 configuration. So far we have automated day 0, day 1, day 2, and some of day 3. Now, we do have to do some manual things through the GUI that are decoupled. So I'm going to pause this recording. I'm going to change the passwords via the GUI because that takes a really long time, and that needs to be done via the GUI before we can get moving on anything else, including the API calls. So I hope you enjoyed part 1. And again, if you would like to run this lab in our environment, please reach out to me. Either send me your Git account, I will add you to the repo, I will sign you a branch. Or if you don't have a Git account, I can just send you an SSH key that you can use, and we will get you up and running with an assigned AZ. And by the way, these environments, like I said, are completely built by just a few variables. And you can see those variables here. They're in a labvars file. So if I were to look in any one of these folders, let's just look in here, you will see this labvars. So this entire automation and environment is completely built off of these 3 variables, which essentially name and region are one and the same. So we could actually strip this down to 2, and then region is just 1 without the A. So in a future release, I'm going to remove this labvars file, and everything will happen automatically through the branch name. But for now, this is the first release iteration, so I'm still using this labvars file. All right, I'll see you on the next recording, which is when we are going to complete the remaining tasks. We are going to use a combination of the GUI and the REST API, as well as some more Python to the CLI. Thank you.